Okay, so question 4 is a projectiles question. Just pause the video if you want to just take a moment just to read that information. So I have at the top, I have split this speed into its two components of 65 cos alpha and 65 sine alpha. Also, they've told me in the question that tan of alpha is 5 over 12. So I've just written out what sine of alpha and cos of alpha are. Also, really important, we often use 9.8 as G, but they've told us to use 10. As the initial direction of movement is upwards, I'm going to take upwards to be my positive direction the whole time. So part A tells us that it would like us to find the time taken for the stone to travel from O to A. So I'm going to need to use my constant acceleration formula here. So I need to have S, U, V, A and T. So S is the displacement. Now, because I've taken upwards to be the positive direction, the displacement is negative 70. U, the vertical component of the velocity, is 65 sine alpha. And I know that that's 65 times 5 over 13. And V, I don't know at the moment, A, that's our gravity. So they've asked us to take 10, and because it's acting downwards, it's going to be negative 10, and T is the thing that I'm trying to find. So the equation I'm going to need is S equals UT plus a half AT squared. So just substituting everything I know, negative 70 equals 65 times 5 over 13 for U, T plus a half times 10 times T squared. If I simplify this, rearrange it, I get 5t squared. Oh, it's actually going to be negative. Sorry, I forgot my negative there. Negative 5t squared plus 25t plus 70 equals 0. And if I solve that quadratic, I get that t is 7 seconds. So that's part A done. Part B asks us to find the speed of the stone at the instant just before it hits the ground at A. So I'm going to need to find the horizontal component, the vertical component, and then use Pythagoras to find the speed. So the horizontal velocity at A will be the same as it was at the start because it doesn't change. So it will be 65 cos alpha. Cos alpha was 12 over 13, so that is just 65 times 12 over 13, which is 60. And then I'm ready to use V equals U plus AT again. So got my suvat above. So V equals U plus AT for the vertical velocity. V equals U, which is 65 times 5 over 13, plus A, which is negative 10, times 7, which is T that I found in part A. And that brings us to negative 45. So that's my vertical velocity. And then all that's left for me to do is to find the speed by using Pythagoras. So 60 squared from here plus negative 45 squared from here, square rooted, and that gives me 75 meters per second. So part C, just one mark at the end, says one limitation of the model is that it ignores air resistance. State one other limitation of the model that could affect the reliability of your answers. So for this one, they have asked us to use 10 for our gravity. So gravity has an approximate. That's 1. It could be that there's wind, so the direction of air. It already mentions air resistance though, so that one's not as useful as this one up here. I prefer this answer. Also, the shape of the stone would have been accepted, but I think that the fact that G is approximate is our best answer there.